the derivatives of all these three parts. First derivative for the first part, second derivative for the second, and the first derivative for the product of these two, the cross product, right? Okay, first part, the derivative of this, the triple product. So using the rule for finding the derivative of the scalar triple product, what is the rule? Just take the derivative of the first one, that is dr by dt, and writing the other two as it is, right? And then plus taking the derivative of the second one, writing first and third as it is. So it is r vector, and then taking the derivative of the second one, that is double derivative of r with respect to t, and writing third one as it is, plus now writing these two as it is and taking the derivative of the third one. So this is r vector dr by dt, and taking the derivative for the third one, that is the triple derivative of r vector with respect to t. Now since the scalar triple products having two equal vectors vanishes, we have two equal vectors over here, we have two equal vectors over here, so these two vanishes, and there is no equal vector in this. So the answer is r vector dr by dt and the third derivative of the r vector with respect to t. So this is the answer for the first part. And now the second part. Likewise in the first part, again we have to, and now the second part, for this we need to differentiate first the first derivative of this triple product, because we have the second derivative of this. Let's find first the first derivative of this, and then again we derivate this. Okay, let me write this as it is. Okay, let's solve this. So taking the first derivative for the first one, so this is dr by dt, writing the second two as it is, plus similarly writing the first and third as it is and taking the derivative of the second one. Similarly third term will be writing the first two one as it is and taking the derivative of the third one. So it is the third derivative of r with respect to t. Because it is having the same vectors, the second term is also having the same vectors, so these two vanishes and we have left up with only the third one. So we need to differentiate only this vector again. So taking the derivative of the third term, that is, so again derivating the first one, writing these two as it is, plus writing first and third one as it is and taking the derivative of the second. So it's the double derivative of r with respect to t, and then writing these two as it is, and we need to take the derivative of the third one. Having the same vectors, it vanishes, and it is not having the same vector, and there is also no same vector over here. So the answer for this is the second term plus the third term, this scalar product, the scalar triple product, this scalar triple product. So this is the answer for the second part. And now let's move on to the third part. For this also let's take the derivative of first one and writing the cross product as it is, plus taking the derivative of this second one. So we have r vector cross product with, if I take the derivative, we have the second derivative of r with respect to t, and its cross product with this one, plus writing these two as it is and taking the derivative of this. Now the cross product of the same vector is always equal to 0. We have the cross product of these two same vectors, so this cross product is equal to 0. These are same, right? So the final answer is first term plus third term. This term is 0, writing the reason. The reason is the cross product of the same vector is 0, being the vector product of equal vectors, two equal vectors, right? Alright, thank you.